This is Algebra 2, Unit 10, Lesson 5, Introduction to Rational Functions. Now, rational functions are simply the ratio of polynomial functions. Basically, it's two polynomials put into a fraction. So it's the ratio of polynomial functions. They take on more interesting properties and have more interesting graphs than polynomials because of the interaction in the numerator and the denominator of the fraction. So in Common Core Algebra 2, we'll be primarily concerned with the algebra of these functions, how to deal with functions that are in fractional form. Okay, so let's look at a couple of rational functions and look at the different characteristics that we have. So let's consider the rational function given by f of x is equal to x plus 6 over x minus 3. Okay, algebraically, determine the y-intercept of this function. If I want to do this algebraically, I have to plug in values. All right, so if I'm doing the y-intercept, what do I know about the coordinates? Well, for the y-intercept, we know that x is going to equal 0. So if I algebraically can figure out what f of 0 is, that'll give me the y-intercept. So this is going to be 0 plus 6 over 0 minus 3, which is 6 over negative 3, which is negative 2. So my y-intercept will be at 0, negative 2. Okay, algebraically determine the x-intercept of this function. So the x-intercept is when y is equal to 0. And remember, hint, a fraction can only be equal to 0 if its numerator is 0. So if I set this up, x plus 6 over x minus 3 is equal to 0, technically, if I want this to equal 0, the bottom can't be 0 because that'll make this undefined. So the top would have to equal 0. So if I multiply both sides here, technically, by x minus 3, over here 2, that's going to cancel this out, leaving x plus 6. 0 times x minus 3 is just going to be 0. So x is going to equal negative 6. So my x-intercept will be at negative 6. All right. For what value of x is this function undefined, and why is it undefined at this value? All right. So if we're looking at x plus 6 over x minus 3, undefined means there is a 0 in the denominator. The denominator is equal to 0. Okay, so what we're looking at is just this part of the equation. All right, what value of x, if I plug in there, will make the denominator equal to 0? Well, if x is equal to 3. So if I take my function here, when x is equal to 3, 3 plus 6 over 3 minus 3, 9 over 0 is undefined. Okay, so you cannot divide by 0. Remember my poster in the room. So if your denominator is equal to 0, that makes it undefined. So if the value of x here that makes the denominator 0 would be 3. So x equals 3. Okay, so based on C, state the domain of this function in set builder notation. Okay, so remember the domain is the list of the x values that work. The only x value that doesn't work is going to be x equals 3. Does any other x value a problem? Will it make the denominator 0? No. We can use negative 6 because that'll make the numerator 0. That's okay. But you can't have the denominator equal to 0. Okay, so based on C, the domain of this function will be x such that x is not equal to 3. Any other value of x will be true. So x is any real number except for 3 because of making the fraction undefined. Okay, so if I want to find all values of x for which the rational function h of x equals x plus 5 over 2x squared plus 11x minus 6 is undefined, verify by using your calculator to evaluate this expression for these values. Okay, now undefined means the denominator is equal to 0. So if I take 2x squared plus 11x minus 6 equals 0, that'll give me the x values that don't work. Okay, so 2x squared plus 11x minus 6 equals 0, I can factor that. That's going to be 2x times x. All right, now the factors of 6, one going over here multiplied by 2 and added together to be 11. Probably 6 and 1. 6 and 1 plus 6 minus 1. Set them equal to 0. 2x minus 1 is equal to 0. X plus 6 is equal to 0. 2x is equal to 1, so x is equal to a half, and x is equal to negative 6. Okay, so those are the values of x. If I plug in x equals 1/2 and x equals negative 6 in here, it's going to make the denominator equal to 0. All right, so let's verify this in the calculator. I'm going to put in y equals. I'm going to put in my rational equation. So I'm going to use the alpha key on this one. So alpha y equals, so it looks like a fraction, pick number 1, and x plus 5. And in the denominator, I have 2x squared plus 11x plus or minus 6. Okay, now what I'm going to do is I want to look at the values for 1/2 and for negative 6. So I'm going to go to my table ask. All right, I'm going to change my table set, and I'm going to go to change this to ask. And then when I'm going to put in, go to my table here, notice I have a blank screen. I'm going to put in 1/2 or 0.5, 1 divided by 2. And notice I get an error. That makes it divide by 0. That doesn't work. Okay, the other one was negative 6. Also an error. So those are the two values that make the equation undefined, because it'll make the denominator equal to 0. You can't divide by 0. Any other number that I put in, say I put in 4, for example, that'll come out to be a fraction. That's a rational number. You can do that. You can use 0. That works. Remember, the numerator would be negative 5. You can have a value 0. That's perfectly fine. It's just when the denominator is 0 that this doesn't work. So for exercise 3, which of the following represents the domain of the function f of x equals x minus 3 over x squared minus 6x minus 16? So why don't we save this one for class? We'll go over undefined for that one, and we'll move on to the next problem. Okay, let's do a little manipulation with composition of functions. We have g of x is equal to 3x minus 2, and f of x is equal to 2x plus 1 over x plus 5. Let's find f of g of negative 2. Okay, now remember, when you're doing these, you start with the inside first, and then apply that answer to the outside. So we want to use g of negative 2, and I'm going to plug that in the g function. 3 times negative 2 minus 2, which is negative 6 minus 2 is negative 8. Then I'm going to take that and plug it into f. So f of negative 8 is equal to 2 times negative 8 plus 1 over negative 8 plus 5. All right, so 2 times negative 8 is negative 16, plus 1 is negative 15. Negative 8 plus 5 is negative 3. Negative divided by negative is a positive 5. So f of g of negative 2 is equal to 5. Okay, f of g of 2. We're going to do the g first with the 2. G of 2 is 3 times 2 minus 2. 3 times 2 is 6, minus 2 is 4. And then take the 4, plug it into this function. 2 times 4 plus 1 over 4 plus 5. 2 plus 4 times 4 is 8, plus 1 is 9. 4 plus 5 is 9. 9 divided by 9 is 1. So f of g of 2 is 1. Now, f of g of x. We want to take the whole function g of x and plug it into f of x. So we take 3x minus 2, and we're going to plug it in everywhere we see x. So this is going to be 2 times 3x minus 2 plus 1, that's the whole numerator, over x plus 5 would be 3x minus 2 plus 5. So everywhere there was an x, I plugged in 3x minus 2. All right, let's simplify this. 2 times 3x minus 2 does distribute is 6x minus 4 plus 1. Then 3x minus 2 plus 5, you can just combine those. Minus 2 plus 5 is plus 3. And combine your terms. That gives you 6x minus 3 over 3x plus 3. So there we go. That is f of g of x. So it's just working with polynomials that we've done before in different ways, and now applying the rational functions to them. All right, exercise 5. Find formulas for the inverse of each of the following simple rational functions below. Recall that as a first step, we switch the roles of x and y. Okay, so if we have y equals x over x minus 2, we want to find its inverse. It would be x equals y over y minus 2. Okay, Now we want to solve for y. All right, so I'm going to put this over 1 just to keep it nice and neat, and I'm going to cross multiply. All right, so x times y minus 2 is equal to y. All right, now I want to distribute. Xy minus 2x is equal to y. All right, I need my y's on the same side and my x's on the other side. So I'm going to move this y over here equals 0, and then I'm going to move this 2x over here. So I'm going to add the 2x is going to be 2x. Okay, now I want to get these y's together, but I have an x and a minus 1 here. So I'm going to reverse distribute this. I'm going to factor out the y. And that gives me x minus 1 is equal to 2x. And then to solve for y, I just have to divide by x minus 1. All right, so that means y is equal to 2x over x minus 1. And that would be the inverse. So it's a little goofy here because you had to distribute out the y, but it does work. Okay, see if you can do b yourself, and we'll go over that in class the next day. All right, last exercise. The function f of x equals x squared minus 8 over 4x is either an even or an odd function. Determine which it is and justify. And based on your answer, what type of symmetry must this function have, and use your calculator to sketch a graph to verify. Okay, so it's either even or odd, so it has to do with the inputs that we're going to use. If we put in opposite inputs, we either get the same output or different outputs. So let's see what we get. All right, we need to pick a value for x. Let's say x is 4. Okay, if x is 4, then f of 4 will give me 4 squared minus 8 over 4 times 4. All right, 4 squared is 16, minus 8 is 8, and 4 times 4 is 16, and 8 over 16 is 1/2. All right, now what if I did f of negative 4? All right, so x is equal to 4, and x is equal to negative 4. So this is the opposite input. What we're going to do is look at what the output's going to be. All right, so negative 4 squared minus 8 over 4 times negative 4. Negative 4 squared is 16, minus 8 is 8, and 4 times negative 4 is negative 16. We get negative 1/2. So we get opposite inputs give opposite outputs. So if this is positive 4 gave me 1/2, but negative 4 gave me negative 1/2. These are opposite outputs. So that tells me that this is going to be an odd function. Function has an N in it. Function. It's an odd function. Okay, so that tells me it is going to be symmetric about the origin. It's going to reflect through the origin. All right, so we want to be able to use the calculator to sketch this. So I'm going to take my calculator. I'm going to y equals. All right, I'm going to put in my function. I'm going to use the alpha key. All right, and it will be x squared minus 8 over 4x. And I'm going to adjust my window, which is from negative 10 to positive 10. And my y's are from negative 5 to positive 5. And when I hit my graph, there we go. And you can see it's symmetric about the origin. It kind of rotates around 180 degrees around the origin. So if I took this and rotated 180 degrees, I'd end up over here. So my graph looks kind of like this. Like that. And then like that. And notice also because it's going to be rotated about the origin 180 degrees. Okay. That is Introduction to Rational Functions.